Hello everyone, welcome back to the channel. In today's video, we are going to start one of the most important topics in computer science, design and analysis of algorithms, commonly known as DAA. If you've ever wondered how applications like Google Search, Instagram, Google Maps, or Amazon work so efficiently, the answer lies in algorithms. Let's understand what DAA is and why it is so important. What is design and analysis of algorithms? An algorithm is simply a step-by-step procedure used to solve a problem. Think about a cooking recipe. A recipe gives you a sequence of steps to prepare a dish. Similarly, an algorithm gives the computer a sequence of steps to solve a problem. For example, searching for a contact in your phone, sorting student marks, finding the shortest route on Google Maps. All these tasks are performed using algorithms. Design and analysis of algorithms is the study of how to create efficient algorithms and evaluate their performance. Why is algorithm design important? Let's imagine two students write different programs to solve the same problem. The first program finishes in 2 seconds. The second program finishes in 20 seconds. Which one would you choose? Obviously, the first one because it is much faster. Now imagine these programs are processing millions of records. Choosing the right algorithm becomes even more important. A good algorithm helps us achieve four major goals. First, faster execution. A well-designed algorithm solves problems in less time, improving the overall performance of software. Second, efficient memory usage. Computers and mobile devices have limited memory. Efficient algorithms use less memory, making applications run smoothly. Third, scalability. As the amount of data increases, the algorithm should still perform efficiently. For example, sorting 100 numbers is easy, but sorting 1 million numbers requires a much better algorithm. Fourth, real-world applications. Algorithms are everywhere. They are used in search engines, social media platforms, banking systems, navigation apps, artificial intelligence, online shopping websites. Without efficient algorithms, these applications would become slow and inefficient. What does analysis mean? Designing an algorithm is only the first step. The next step is to analyze it. Analysis means measuring how efficient an algorithm is before implementing it. Instead of simply asking whether an algorithm works, we ask questions like, how fast is it? How much memory does it use? Will it still perform well if the input becomes very large? This helps us compare different algorithms and choose the best one. Factors that affect algorithm performance. The performance of an algorithm mainly depends on four factors. Problem type. Different problems require different algorithms. For example, searching data and sorting data are two completely different problems. Input size. Input size refers to the amount of data. For example, 10 numbers, 100 numbers, or 1 million numbers. As the input size increases, the algorithm's performance also changes. Time complexity. Time complexity tells us how the running time of an algorithm grows as the input size increases. We'll study different notations like big O, big omega, and theta in the upcoming videos. Space complexity. Space complexity measures the amount of extra memory required by an algorithm while solving a problem. An ideal algorithm should use less memory while still maintaining good performance. Understanding the workflow. Now look at the diagram at the bottom of the slide. It shows the complete journey. We begin with a problem. Next, we design an algorithm to solve it. Then, we analyze the algorithm by measuring its efficiency. Finally, we select the most efficient solution. So the overall process is problem to algorithm, design to analysis to efficient solution. Real life example. Let's take Google Maps as an example. Suppose you want to travel from your home to your college. Google Maps first identifies the problem. Then it uses path-finding algorithms to calculate different routes. Next, it analyzes which route is the shortest and fastest. Finally, it displays the best route to you. This entire process is a practical application of design and analysis of algorithms. What is an algorithm? First, let's talk about algorithm. An algorithm is a step-by-step procedure or a set of instructions used to solve a specific problem or perform a particular task. For example, think about making a cup of tea. You follow a sequence of steps. Boil water, add tea powder, add sugar, add milk, filter, and serve. These steps form an algorithm. Similarly, computers solve problems by following well-defined algorithms. The second part is design. Algorithm design means creating an efficient method to solve a problem. Instead of writing code immediately, we first decide how the problem should be solved. There are several popular algorithm design techniques. Let's look at them one by one. Divide and conquer. Break a large problem into smaller problems, solve each one, and combine the results. Greedy method. At every step, choose the best immediate option, hoping it leads to the optimal solution. Dynamic programming. Solve overlapping subproblems once and store the results to avoid repeated calculations. Backtracking. Explore all possible solutions and backtrack whenever a solution path fails. Branch and bound. Mainly used for optimization problems by eliminating branches that cannot produce better results. Each technique is suitable for different types of problems. What is algorithm analysis? Now let's move to analysis. After designing an algorithm, we need to evaluate how good it is. Algorithm analysis studies the performance of an algorithm. There are two major factors. Time complexity. Time complexity tells us how much execution time an algorithm takes as the input size increases. A faster algorithm generally has better time complexity. For example, an algorithm that takes O of n log n time is usually better than one taking O of n squared for large inputs. Space complexity. Space complexity measures how much memory an algorithm requires during execution. Some algorithms use less memory, while others need extra storage for temporary data. A good algorithm tries to balance both time and memory efficiently. Why is DAA important? So, why do we study design and analysis of algorithms? Because it helps us build faster programs, reduce memory usage, handle large amounts of data efficiently, compare different algorithms, choose the best solution for real-world problems. Without algorithm analysis, two programs may produce the same output, but one might take seconds while the other takes hours. Thank you so much for watching this video. I hope you found it helpful and learned something new about design and analysis of algorithms. If you enjoyed the video, please like, share, and subscribe to my channel for more programming and computer science tutorials. Don't forget to press the bell icon so you never miss an update. Thanks again for watching, and I'll see you in the next video. Happy learning!